We are continuing our notes on solving quadratics. So another method we have is solving using difference of squares. So sometimes we run into an equation that looks like this, where we have our term that's being squared, and then we have some constant, and we're missing that middle term. It's called difference of squares because our first term is squared, and our k is also a perfect square number. So that could be 1, 2, 4, 9, 16, 25. We're just going to list them all out. So perfect squares, 1 squared is 1. I don't know why I put 2. I just realized that. Get rid of that. 2 squared is 4, 3 squared is 9, 4 squared, 5 squared, so on and so forth. If you can recognize these, it'll make it a lot easier, but we're adding them into our notes. So what we want is we still want our equation to be equal to 0. So if I want to solve this using difference of squares, I'm going to subtract 16 from both sides first. So I have x squared minus 16 equals 0. Well, I have a perfect square here, and 16 is a perfect square, and I have a subtraction in the middle. So that means when I factor it, I'm going to have x plus 4 and x minus 4. You could go through the long way of making your t-chart, numbers that multiply to negative 16 that add up to 0. Since we're missing that middle term, our b value is technically 0. You would still get positive 4 and negative 4 as the pair that you want. When we set these each equal to 0, we get x equals positive 4 and we get x equals negative 4. I realize I should have wrote them flip-flopped. That's okay. So for this one, again, I want it equal to 0, so I'm going to subtract 89 from both sides. So I get x squared minus 81 equals 0. Again, perfect square here, and I have subtraction because I need the difference of them. So I would get x plus 9 and x minus 9. I break them apart, set them equal to 0. I get negative 9 and positive 9 as my two roots. For this one, it's already equal to 0, but if we look back up here, I need my a value to be 1. So I'm going to divide everything by 2. When I do that, I end up with x squared minus 49 equals 0. Well, 49 is in our list, and 49 is 7 squared. So for my final answer, I get negative 7 and I get positive 7. Scoot this up a little bit. Feel free to pause the video and do the ones underneath. I am going to do them quickly. All right, so I have my roots. I did purposely skip a few steps here, so I did have to subtract 21 on both sides, and I got negative 9, so I knew it was positive 3 and negative 3. For this one, I had to subtract 185 from both sides and then divide by 3, so I get this, and then I know 64 is the perfect square of 8, so I get positive 8, negative 8, and then this one is already perfect. I get 11 and negative 11. We have one more method to go through. So for the very last thing is our foolproof method. When in doubt, we use the quadratic formula. This works for any quadratic because sometimes we can't factor or sometimes we can't use the difference of squares. We can always use the quadratic formula. So whenever we use this, we want to make sure that we are always plugging our numbers in using parentheses. And then we want to simplify it in 3 parts. So I'm going to do these first 2 here, and then I'm going to leave the last 4 for you to do on your own. So the first thing I want to make sure is I have it in standard form, and it's either equal to 0 or equal to y. If it's not in standard form, we have to put it in standard form. So from here, I notice it is in standard form, so I have my A, B, and C. If you want to label them on the side, you can. So my A value is a positive 1. My B value is a negative 5, since that minus sign is connected. And my C value is a negative 14. When I use my quadratic formula, I have my negative, and then inside parentheses, my negative B. I'm sorry, inside parentheses, negative 5, which is my B. Then I have b squared minus 4 times my A value times my C value, all over 2 times A. I'm going to simplify this in 3 steps. So I first simplify the part in front of the plus or minus, which is going to be positive 5. Then I'm going to simplify the part after the plus or minus. So I'm going to show you what my calculator looks like. So I'm going to type in my square root symbol. So I'm going to hit second and then x squared. So my square root comes up. Then I have to do another parenthesis for my negative 5 because this parenthesis is just for the square root. So negative 5 squared minus 4, 1, and then negative 14. With my negative sign, I want to use the button at the bottom next to the decimal, and then this is a minus. And then I hit enter. So what that means is this whole piece is 9. And then my denominator, 2 times 1 is 2. So move this out of the way. So when I simplify this, I'm going to break this apart, and I'm going to do 1 with the plus and 1 with the minus. So 5 plus 9, that is 14. 14 divided by 2 would give me 7. 5 minus 9 is negative 4. Well, negative 4 divided by 2 is negative 2. So we found 7 and negative 2. Now, I could have factored this. If you can tell that you can factor it and that's faster for you, great. If it's not faster for you and you want to use a quadratic formula, great. Either way, we still found our roots or our x-intercepts. For the one on the right, I'm just going to start the same way. So I'm just going to use the quadratic formula. I'm not going to look for a GCF. I just need to find A, B, and C. So I know my A is 7, my B is negative 32, and my C is negative 60. So I'm going to plug in my values. So I have my negative and then parentheses my B value, plus or minus the square root of B squared minus 4 times my A times my C all over 2A. So I'm going to simplify this. I get positive 32. And then I have to do my whole square root piece. So I'm going to show my calculator again. I'm going to do the square root. Another parenthesis, negative 32 squared minus 4, 7, negative 60, and I get 52. So that whole thing turns into 52. Then my denominator, 7 times 2, 14. So I'm going to do 1 with the plus. So 32 plus 52 over 14, and then 1 with the minus. If you are using a calculator for this, so for this top one, 32 plus 52, you have to hit enter first and then divide by 14. Or you have to put your numerator in parentheses. So I could do parenthesis 32 plus 52 divided by 14. And then we get our x-intercept is 6. So that's one of them. For the bottom one, 32 minus 52. And I get a decimal. I'm just going to round it to -1 point. I want 4.3, but I'm a little close to the edge there. And that's my other root. If you don't put parentheses and type it in all at once, your calculator follows PEMDAS and will do the division before the subtraction or before the addition, and it will only divide the 52 by 14, not whatever the numerator would end up being. And so that's why it's important that you have the parentheses or you do the numerator first, hit enter, and then do your division. So you can do the 4 U tries at the bottom. The answer key for those are posted with the note key.